Okay, so now today let's starting to solve the challenge problem of the chapter 11 for the intro to algebra. So the first question. So we have the consecutive positive odd integers. Okay, so consecutive positive odd. So we can parameterize this. It's the 2n minus 1 and the 2n plus 1 and the 2n plus 3. Okay, then we have the b square minus the a square is 2n plus 1 square minus the 2n minus 1 square. According to the difference of the square, we have the 2 times the 4n is equal to 344, and the c square minus the b square is equal to 2n plus 3 square minus the 2n plus 1 square is equal to 2 times the 4n plus 4. Then this one will equal. So from here we can solve the 4n. 4n is equal to the 172. So this one is the 344 plus 8 is 352. Okay. Second problem. So we want to evaluate 29 square. So 29 square is 30 minus 1 square is equal to the 900. Okay. Then minus the 60 plus 1 is 841. Okay. And the b is 299 square is equal to 3 times 10 to the 2 minus 1 square is equal to 9 times 10 to the 4, then minus the 6 times 10 to the 2 and plus 1, right? So this one is 9 0. Yeah, and then we subtract the 600, right? So it is 89400 plus 1 is 89401. Okay. Then the c is 299 square, right? Is 3 times 10 to the 3 minus 1 square is 9 times 10 to the 6 minus the 6 times the 10 to the 3, then plus 1. So we can see the final is the 1, right? And the 10 to the 3, so this 0, 1, 2, 3, right? So this one is 4, 4, 5, 6, right? So it's 8, 9, 9, 4, 0, 0, 1. Okay, so now we want to solve this one. So let's see, D is the 2 with the 1, 2, 3. Okay, with a 1, 2, 3, 4, 5, 6, 7. Okay, then it's from 0, 1, 2, 3, 4, 5, 6, 7. So this is the 10 to the 7 through 3 times the 10 to the 7 minus 1 of the square is 9 times 10 to the 14 minus the 6 times 10 to the 7 plus 1. Okay, so now let's see the digits of this. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, right? So 10 to the 7 here, right? It's minus 6 times 10 to the 7. Okay, so 10 to the 8 minus 6 times 10 to the 7, so there will be 4 here, right? And so here's 8 is 9, 9, 9, 9, 9, 9. Okay, so we have 6 nines, 1 8. Then the final one is all the way down to here, it's 1, right? So now we have the 8 plus the 6 times 9 plus 4 plus 1 is the 54 plus 5 plus 8 is the 61. Uh, uh, let's see, it's the 59 plus the 8 is the 67. Okay, now next. So let's calculate this. Okay, so here is the, let's write the general form. Okay, so we can see this one, right, is let's see the first number. Let's see the a equals 1998, right? Then the a, let's see the a plus 1 equal 9998, then a equal 1997, right? So we can see the first we are calculating is the a square minus the k square, right? And times them together, where k can equals, multiply them together, k is from the 0 to the 1996. Okay, I'm sorry, it's a plus 1 square. Okay, then we divide it by k equals from 0 to 1996, right? And the a square minus the k square. Okay, so use the square of the difference, right? Let's see. So it is the time together is from k0 1996, right? So we have the a minus 1, a plus 1 minus k, then a plus 1 plus k divided by the a minus k times the a plus k. Okay, so we can differentiate this one, this cut into two pieces. Okay, so we can have first piece and second piece. So this one is equals to the first product, a plus 1 minus k and a minus k. Okay, then times the second product, a plus 1 plus k and a plus k. Okay, so now let's solve. This is called a, this is called b. Now let's solve the a first. The a is equal to, let's write some term. Okay, so it will be the a plus 1 is 1998 minus the 1996, right? And then 1997 minus the 1996 times the 1998 minus the 1995 and the 1997 minus the 1995 up to the 1998 minus 0 and the 1997 minus 0. So let's see. Okay, so this one is 2, this one is 2, this one is 2, right? And this one is 3, this one is 3, right? So the final piece of the a will leave this part and this part. So it is equals 1998 here. Let's see the second one, the b, right? The b is the 1998 plus the 1996, then 1997 plus the 1996 times the 1998 plus the 1995, right? And the 1997 plus the 1995 times, it's the final one is 1998 plus the 0 and the 1997 plus the 0. So you can see this one and equal to this one, right? So this cancel. So after final one, you will leave this one cancel this, right? So we have the 1998 plus the 1996 divided by 1997. So there's 2 times 1997, so it's 2. Then we have the a times b is equals 2 times the 1998 is 2000 is 3996. Next, so let's rationalize the denominator. Okay, so this one we always use the difference of the square is 2 the root 4 2 and the 2 plus the root 4 2. Okay, so it's 2 plus the root 4 2. Then this one is equal to the is equal to the 4 minus the root 2 and the 2 of the 2 plus root 2 root 4. Okay, 2 root 4. Then we do the square of the difference again. 4 plus the root 2 and the 2 and 2 plus the 2 root 4 and the 4 plus the root 2. So this one is the answer is the 14 over 2, 2 times the 2 root 4 and 4 plus the root 2. So cancel is 7. So it's 7. Next. So without calculator, we want to find the largest prime divisor, right? So you can see here is the 512, is 10, 2. The most very sensitive is it's the 2 to the 6 times to the 5 to the 6. So now let's see the 5 to the 6 is A and the 2 to the 6 is B. Then we have the A squared minus the 2 times A times B, then plus the B square is equal to the A minus B bracket square. So then we have the 5 to the 6 and the minus 2 to the 6 square is equal to the we use the square of the difference again is 5 to the 3 minus 2 to the 3 of the times the 5 to the 3 plus 2 to the 3. Then after that is the square. So here is the 125 minus 8 is 117 times the 125 plus 8 is 133 of the square. Then this one have a factor of 9. So 9 times the 1 and 13 times the 133 is the 7 times 19 of the square. So the largest prime divisor is 19. Okay. So two non-zero real numbers, so a, b does not equal 0 belong to the real number. Then we want to satisfy a, b equal this. We want to find this value, right? So there are something you can see as we can solve the a in terms of the b here, right? Or solve the b in terms of the a here. So we can, from the a b equals a minus b, we can see the a plus 1 times b is equal to a. Then we can solve the b is equal to a over a plus 1. Okay, now let's apply this one to here. So a over a plus 1 plus the b is a over a plus 1 divided by a, then minus the ab is a squared than a plus 1. Then this one equal the cancel is a plus 1 plus the 1 over a plus 1 and minus the a plus 1, the a squared. So it is equal to the a plus 1, a squared plus the 2a plus 1 minus the a squared. So it's 2a plus 1 over a plus 1. So it equal to 2. Okay, so this one. So let's see how we can express x plus y, right? So this x5 plus y5, okay, is equal to the x plus y times something, right? So first you need x5, right? You need x4 and y4, and you also need all of them positive, okay? Now we can get it. It's like 3y plus x2 y2 then minus x y3. Okay, let's see this. Okay, how they can cancel. Let me show you. Okay, so x times the, let's see, this is the pxy. Okay, so x times the pxy is equal to, let's list the term, is x to the 5, right? And x minus x4 to the y plus x3 to the y square and minus x squared to the y cube and plus the x to the y4, right? And the other one is the y times the pxy. Okay, so the first is y x4, right? So it's plus x4 to the y, then minus the x3 of the y square, then plus the x squared of y3, then minus the x of y4, then plus of the y5, right? So you can see when you add them together, when you sum them together, you will have this cancel, cancel, cancel. So only left is x5 and the y to the 5. So that's why you can see the x5 plus the y5 is equal to x plus y. Then starting from is x4 minus x3y plus x squared y squared, then minus the x of y cube and plus the y4. Okay. Then you can also do the same thing for the x7 to the y7, right? So this is the A, and I also talk about the B already done, right? You can follow the same method. And the C is also very similar. x2n plus 1 plus the y2n plus 1 is equal to the x plus y, right? You're starting from the x2n, the next term is negative of x2n minus 1y, right? And until to the next y 2n minus 1 and plus the y of the 2n. This is the C. And for D, it asks you why it doesn't work for the x for the even number, right? For even power. So for D, you can see x2n plus the y2n. You cannot follow this. Let's see what happens here, okay? So from x2n y to the 0, right? The y power is increasing from the 0 to the 2n, right? So there are 2n plus 1 terms, right? Also we can see this is the positive 1, right? And negative 1, right? So positive, negative, and this is the positive, negative. So we come in pair. So we have the pair. We have equal plus 1 coefficient and minus 1 coefficient, but the last one is plus 1, right? So we have one more plus 1 coefficient. So we need to have all terms to make it possible, right? Okay, it's all terms. Now let's see. If the x2n plus the y2n also follow this form, means x plus y, right? Then x2n minus 1 until to the y to the 0 until to the y2n minus 1, right? So you can see here we have the even terms. Okay, so for the even terms, you must have the positive 1, negative 1, positive 1, negative 1. So the last can only be the negative 1. Okay, so that's why it doesn't work. So this one, okay, it's very simple. So you can see this is the a square, the b square, the c square, right? And then you have the 1, 1. 1 equals a times b. You have the 2, 2. Then 2 equals the a times c. Then you have the 3 and the 3. 3 equals b times c. So that's why you can see you have the a plus b plus c. A plus b plus c, right, is a squared plus b squared plus c squared plus the 2ab plus the 2bc plus the 2ca. Okay, this one. So let's how many different triples numbers can satisfy this a, b, c integers belong to the, here is the positive integers and also range from the 1 to 5 inclusive. So now let's see. Okay, so the a square plus the bc is equal to the b square plus ac. So we can get the a minus b and the a plus b, then minus the over c and the a minus b, right, is equal to 0. So we can have the a minus b and the a plus b minus c equals to 0. Okay, so now we do the casework. Okay, for the casework, you can see if a equals b, basically you can pick any c, right? So a equals b have 5 choice, right, from 1 to 5, and for each one you have 5 choice to take the c, so we have 25 for this case. Okay, this is the case 1. Then case 2, the case 2 is a is not equal to b, right? So we can list as a less than b first. Okay, then we double that. Okay, so c, now let's deal with the c. So a plus b equals c, right? Let's see. So if c can be from the, at least is 2, right? 2, 3, 4, 5. Let's see. Okay, if c is 2, right, so you must be 1, 1, but a could not be that, so it's only 0 possibilities, right? Then 3 is 1 and 2, right? 4, because a less than b, so it's only 1 and 3. 5 is the 1 and 4 and 2 and 3. So you can flip it. So this one times 2 at 2 choice, this one 2 choice, this one have the 4 choice. So here we have another 8 choice. Then total together, add together is the 33 solutions. Okay. Next, so a triangle with whether it should be a right triangle if the 3 sides are like this. Okay, let's compare. So the first very obvious is 1, 1, 2, 5, and 10 to the 2n plus 1 plus 8 is greater than the 1, 1, 2, 5, then 10 2n plus 1 minus 8. Okay, and the second one, and it's also, we can also see 10 to the 2n plus 1 plus 8 is also greater than the 6 times 10 to the n plus 2. Okay, let's prove it. So let's see this, the 1, 1, 2, 5, then of the 10 to n plus 1 plus 8 will greater than the 1, 1, 2, 5, then times 10 to the times 10 and to the times 10 times the 10 to the 2n, and whether it is greater than the 600 times 10 to the n, right? So it is equivalently to say whether equivalently to see whether the 11250 times 10 to the n greater than the 600, right? So n is positive integers, so this is the yes. So that's why, you know, this is the biggest number, right? So the longest size. Now we are to verify the verify right triangle, right, is the Pythagorean, right, is the a square plus b square equal to the c square. Now we need to prove, we need to verify it. Okay, so it's 1125 times 10 to the 2n plus 1 plus 8 square, whether this one equals 1125 times 10 to the 2n plus 1 minus 8 bracket square plus the 6 times 10 to the n plus 2 of the bracket square. Okay, so this is the equivalently to verify it's 1125 times 10 to the 2n plus 1 plus 8 of the square minus the 1125 times the 10 to the 2n plus 1 minus 8 of the square, whether this one equals 6 times 10 to the n plus 2 and to the square. And this is also equivalently use the difference of the square, then you can see it is the it will be the 16 times the 1125, these two together, right, is 22250 times 10 to the 2n plus 1, and will whether be equal to the 36 times the 10 to the 2n plus 4. Okay, so it's also equivalently to test, let's take out this one. So it's 9 times the 10 to the 3, whether this one equals to the 4 times the 2250 times the 10. No, yeah, whether this one equal this. So this one will be equal to the 9,000. Whether this one equals to the 10 to the 3, then the answer is yes. So that's why it is the three numbers can construct a right triangle. Next, so this one we also use the algebraic calculation. Okay, so because you can see this, right? So the first thing we think is to get the pair of the use the square of the difference. So now let's see, a equals to the 51.5. Then we can see the 50 times the 51 times 52 times 53, right? So we can parameterize it, a minus half and a plus 1/2 and a plus the 2/3 and I mean 3/2 and a minus the 3/2. Then we can get it in pair, use the difference of the square, so we can see the plus 1, right? Plus 1. So we can see this is the s. Then let's say s equals to the a square minus the 9/4 and the a square minus the 1/4, then plus 1. Now we can do is the a to the 4th minus the 5 to the 2 of the a square plus the 16/9 plus 1. Then we can see is a to the 4 minus the 5/2 of the a square plus the 16/25. So this one is a square minus the 5/4 of the square. Okay, so now we see this, right? So now we can solve. This is the final answer we want to calculate. What's the s square, right? Equals to the what is s? Equals to the a square minus the 5/4. Then what is a? A is the 51. Is the 51 plus 1/2 the square minus the 5/4. Okay, so now let's see. Okay, so you can calculate is the 4 to the 103 of the square minus 5/4. Final answer will be 2651. Okay, next. So we want to factorize the x to the 4 plus 4y to the 4, right? So what you can see is we need some to make it, in order to factorize, we need a perfect square minus some perfect square, right? So the thing we want to go with is the x to the 4 plus the 4y to the 4 plus 4x square y square, then minus the 4x square y square. Okay, so for this one we can have its x square plus the 2y square of the square minus the 2xy of the square. So now you can do is x square minus the 2xy plus the 2y square. Okay, now the other we have the x square plus the 2xy plus the 2y square. So this is the factorization. Okay, next. So the similar thing, okay? So 2 to the 22 plus the 1, right? It's 1 square and the 2 to the 11 square. Then you can see in order to factorize, we need the 2 times the 2 to the 11. Then we need the minus the 2 times 2 to the 11. This is the 2 to the 12, right? So this is the square. So that's why we can write as 211 plus 1 of the square minus the 2 to the 12, okay? Is this one is 2 to the 6 of the square. So now use the difference of the square is 211 plus 2 to the 6 plus 1 and 211, okay, minus 2 to the 6 plus 1. Next, so this one, let's see, okay, so we can have the root 2 minus 1 of the 1 times the root 2 minus 1 of the negative root 3, then it's the root 2 plus 1 of the 1 times the root 2 plus 1 of the root 3. So here, okay, so this part is equal to the 1 over root 2 plus 1 and the root 2 minus 1 and the 2 the root 3. So it's equal to the 1 over 1 root 3 is equal to 1. Okay, so this part is done. And this part is simple, right? So it's the root 2 plus 1 and the root 2 minus 1, then root 2 minus 1 of the square. So you can see it is the 3 minus 2 root 2. Okay, so the last one is without a calculator, find the sum of the digits of the numbers. Okay, let's say a equals 2000. Same thing, right? We need to try to fully use the difference of the square. So we have the a minus a plus 3 to the 4th and the minus the a minus 3 to the 4. Then that's using the square of the difference is a plus 3 of the square minus the a minus 3 of the square times the a plus 3 of the square plus to the a minus 3 of the square. Then this one is equal to, then it's the 6 times the 2a. Okay, so this one is equal to 2a squared plus 9 and 9 is 18. Okay, so now this one is 12a is 24 times 10 to the 3. Then this is 2 times the 10 to the 6 plus 18. Okay, then this one is, we have this one is 48 times 10 to the 9 plus 24 times 18, then times 10 to the 3. 10 to the 9. Okay, so now it's 48 times 10 to the 9 plus the 28 is 480 minus 48 is 432. So it's 432 times 10 to the 3. So the sum of digits is equal to 4 plus 8 plus 4 plus 2 plus 3. Then it's equal to the 10 plus the 11 is 21. Okay. So yeah, that's it for the challenge problem of this chapter. Thank you.